So we just finished taking a look at the Java streams implementations, parallel streams implementations. Let's go ahead and turn our attention to the RxJava implementations. And you can see here, there's a couple of them. One of them is going to use what we call the flat map concurrency idiom, and the other is going to use something called the Parallel Flowable implementation. So there's sort of two different ways of doing parallel processing with Java, with RxJava. As you can see, they're very similar in terms of what we pass. We pass in the download and store image and the download and store image BT. We left out the other one that used the adaptive approach. We could add it there if we wanted to, just wanted to show how this worked. And you can also see that we pass in a scheduler here that's the IO scheduler. With both RxJava and Project Reactor, they have these scheduler classes and they define where the threads come from when you want to do computations. So we're going to use the IO pool, which is optimized for IO. And let's go ahead and take a look here at the run flat map implementation. So this particular implementation is going to be very similar in structure to what we did before with streams. We're going to garbage collect things, delete the downloaded images, and then do a timed run to test the flat map concurrency idiom version of this stuff. So let's take a look at that. So this is how you do parallel processing using the flat map concurrency idiom with RxJava. And to make this a little bit more concise, I wrote a little utility class called RxUtils that do various things. So this, for example, will take a URL and turn it into a concurrent observable. As you can see here that we use the observables from callable factory method to emit the item that's passed in. And then we go ahead and turn this thing into a concurrent observable if we're instructed to. And so again, depending on the values of these things, you either get a common fork join pool observable or just a regular observable. If you get the one that's going to run in the common fork join pool, then we go ahead and we say to that observable, please subscribe yourself to the common fork join pool scheduler. So that's also kind of showing how you can integrate RxJava stuff with Java parallel streams and modern Java stuff. So now we've got ourselves an observable that knows how to be used in a thread pool, which is what we're trying to get here. And then we're going to essentially create a mapping that will map the download and store image, which in this case will just download the image using whatever approach we want to do. So we get this local variable called download and store. Then what we're going to do is we're going to apply the flat map concurrency idiom as follows. We're going to say observable from iterable, which is a factor method in RxJava that takes a list and turns it into an observable. And as you'll see in more detail later in the course, an observable is a reactive type that's capable of emitting 0 to n or 0 to infinite number of items. And in this particular case, we're going to have it emit the URLs that are part of the URL list that we got, corresponding to the URLs that are available on my website. Then we apply the RxJava flat map concurrency idiom. There's flat map concurrency idioms for both RxJava and Project Reactor. They work essentially the same. And what they do here, you can read it as follows. You can basically say for every URL in this observable of URLs, which is kind of like a stream, go ahead and take each URL and emit it and subscribe it on the scheduler that's being passed in here as a parameter. So this scheduler is the one that's passed up here. In this case, it was the IO scheduler. And so what this is saying is for every item, have this item run in the parallel IO scheduler and download and store the image. And download and store image was basically this method up here. And so that's what we're able to do there. And what we do then is we collect all the results into a list. So after all the computations are finished being run concurrently in this common pool of threads, then we go ahead and collect the results. And the last thing we do here, because this is RxJava, is we use a very helpful method called blocking subscribe. And that just basically waits for all the asynchronous computations to finish and then it prints the results out. So this is how you do this is one way you can do parallel processing with RxJava using what's called the flat map concurrency idiom. Let's now pop back up here a second, and we'll see that there's actually another way of doing this shown here called run parallel flowable. And run parallel flowable has very similar structure to what we've seen before, except it calls this test download parallel flowable method. And you can see here, this is much less cumbersome than using the flat map concurrency idiom. The flat map concurrency idiom, once you know it, isn't too hard, but it's a little bit cumbersome. So this approach here, instead, will make ourselves a parallel flowable. And you can see how it works here. We basically go ahead and say, turn this thing into a flowable, and then make a parallel flowable and run this on the common fork join pool. So this is how you make what's called a parallel flowable in RxJava. And then once you've done this, you can then go ahead and say, apply all these functions, or apply this function multiple times on each of the threads that are part of the parallel flowable. And when everything's done, we turn it back into a sequential, observable, or flowable in this case, and then we collect the results into a list. So all this is really showing is there's a couple different ways to get concurrency and parallelism in RxJava. One is to use this flat map concurrency idiom that we show up here, which works in any version of Java, and it works with observables. Then in later versions of RxJava, if you want to avail yourselves of parallel flowable, you can do that. And it's arguably somewhat simpler to program than doing the version that uses the concurrency idiom. See how we're doing on running here. That's still plugging away. So that was the RxJava implementation. Let's now go ahead and pop out of here and go take a look at the final version, which are the Project Reactor tests. And you can see here we have a bunch of different approaches. We have one that uses flat map, a couple of different flat map approaches, one that uses the blocking task, one that doesn't. And then we also have a couple of parallel Flux versions that illustrate yet different ways of being able to process things in parallel with Project Reactor. Now, when we go and look at the Project Reactor implementation, you'll see it has quite a bit in common with the one that's the RxJava, and that's not by accident. They're very similar. They're not identical, but they're very similar. So if we take a look at the one that uses flat map and the flat map concurrency idiom, you'll see it looks almost identical to the RxJava version we saw before using observable. Except in this case, we use a Flux instead of an observable. We use the from iterable method. The observable has one too. We convert the URL list into this Flux, which is just a stream, if you will, of URLs. We apply the Reactor flat map concurrency idiom, which is pretty much identical to the RxJava concurrency idiom. And it goes ahead and takes each URL, subscribes the processing to run on a scheduler, and then applies the download and store image function to do the processing in the background. After all that is done, we collect the results into a list, and then we print the results and we block until all the processing is done. So that's using the flat map concurrency idiom with Project Reactor. Again, very, very, very similar to the one that we saw earlier with RxJava. Then down here, we have the parallel Flux version of this. And this is also very similar to what we saw earlier with RxJava. Again, we convert the URL list into a Flux. We tell the Flux we want it to be running in parallel. We tell it to run on the scheduler. And then we do the processing of the downloading and the storing of the images in parallel. When we're done, we convert the parallel Flux back into a Flux, and then we collect the results into a list, and we block until everything is done. So quite a bit of commonality in terms of the reactive programming frameworks. They're slightly different, but not different they're different in accidental ways, names of methods and so on, but the capabilities that they provide are essentially identical to what we saw earlier with the other version. This thing is still cranking away. We're not going to wait for it to finish. But what you would find when it finally finishes is that the Project Reactor versions are typically the fastest. So I encourage you to try this on your own computers to see how it works for you. But I think you'll see that the Project Reactor implementations tend to run faster than the RxJava implementations. And usually the parallel streams is sometimes it's in third, sometimes it's in second, depends. But Project Reactor is almost always the fastest. So that's a good sign. And you'll also find that the versions that use the adaptive versions or capabilities of Common Fork Join Pool perform better because they have more cores humming along in parallel and therefore don't have to wait while things are blocked.